You need to pull a fallen tree off a trail, or hoist a support beam into place, or stop yourself from sliding off a cliff edge, and you reach for the strongest single thing nature has handed you. A vine, a strip of bark, a length of animal sinew, and it does not hold. It stretches, frays, and snaps, because nothing growing on the surface of the earth is strong enough on its own to survive that kind of pulling force. You cannot make the vine thicker. You cannot make the sinew tougher. What you need is a way to take something weak and turn it into something strong without changing what it is made of at all. And the answer, when someone finally figured it out, sounds almost too simple to be an invention. Take several weak strands, twist them in one direction. Then take several of those twisted bundles and twist them together in the opposite direction. The friction generated between the fibers locks them together so tightly that the combined strand becomes dramatically stronger than the sum of its parts, strong enough to hold weight that none of the individual fibers could ever survive alone. That invention is rope, and it is so old, so deeply buried in human prehistory, that it may predate stone tools sharp enough to carve wood, predate agriculture by tens of thousands of years, and predate our own species entirely, because the oldest direct evidence of cordage ever found was not made by a Homo sapiens. It was made by a Neanderthal. In 2020, a team led by paleoanthropologist Bruce Hardy at Kenyon College in Ohio published a discovery from a rock shelter called Abri du Marais in the Rhône Valley of southeastern France. Stuck to the underside of a stone tool, buried in sediment dated to somewhere between 52,000 and 41,000 years ago, was a fragment of cord. 3 bundles of fiber, stripped from the inner bark of a tree, had been twisted clockwise into yarn, and then those 3 yarns had been twisted together counterclockwise into a single cord. That counter-twisting is not a small detail. It is the entire trick. Twist 3 strands the same direction, and they simply unravel the moment you let go. Twist them opposite to the twist already inside them, and the cord locks itself, holds its own shape, and gets stronger the harder you pull it. A Neanderthal understood that, not by accident. Hardy's team pointed out that producing a cord like that requires tracking multiple operations at once, remembering which strand goes where, in which direction, in what order. That is not a skill you stumble into. That is a procedure, held in memory, executed in sequence. For decades, Neanderthals were pictured as blunt and simple. A twisted piece of string, barely visible without a microscope, quietly took that picture apart. Rope, it turns out, may be older than fire-hardened spears, older than cave paintings, older than almost anything else we count as evidence of complex thought. And the deeper archaeologists dig, the earlier the evidence gets. In 2015, excavators at Hohlefels Cave in southwestern Germany, working under Nicholas Conard of the University of Tübingen, pulled 15 fragments of mammoth ivory out of the ground. Pieced back together, they formed a single tool, about 20 centimeters long, with 4 holes drilled through it, each one lined with tight spiral grooves carved into the inner wall. For years, similar objects had been filed away in museum drawers, labeled shaft straighteners or ceremonial batons. Nobody could explain the spirals. Then Conard, working with Virlo Rots at the University of Liège, built a replica and tested it. 4 or 5 people, threading plant fiber through the spiral-cut holes and pulling in coordination, produced 5 meters of thick, sturdy rope out of cattail reeds in about 10 minutes. The tool dates to roughly 35,000 to 40,000 years ago. It is not evidence that someone once made a piece of string. It is evidence of a production line, a team, a technique, and a purpose-built machine for turning weeds into weight-bearing cordage. Tens of thousands of years before anyone laid the first stone of a pyramid. And rope was not only being twisted, it was being chosen, processed, and dyed. In 2009, a researcher named Eliso Quavadze, working with the Georgian National Museum, was examining pollen samples from Dzudzuana Cave in the foothills of the Caucasus when she noticed something under the microscope. that had nothing to do with pollen. Flax fibers. Thousands of them, more than 34,000 years old. Some of them spun, some knotted, some dyed black, turquoise and pink, using plants gathered from the surrounding hills. Before this discovery, the earliest known fiber technology came from imprints in fired clay at a site in the Czech Republic, dated to roughly 28,000 years ago. Dudzuana pushed the timeline back by 6,000 years in a single afternoon of lab work, and it did something else too. It proved that early cordage was never purely functional. Someone in an Ice Age cave was choosing colors. So here is the strange part. Unlike the wheel, rope did not require rare materials, precision carpentry, or a perfectly round hole cut around a perfectly round shaft. The raw material was everywhere: grass, bark, reeds, sinew, hair. Nearly every environment on Earth offered something twistable. The obstacle was never the material. The obstacle was the sequence. Making a strong cord means holding multiple twisting operations in your head simultaneously, tracking direction, tension, and order across several strands at once, and getting every step right, because a single reversed twist and the whole cord falls apart in your hands. Researchers studying the Ivory compared that cognitive load directly to the structure of language, the same kind of layered, rule-based sequencing that lets a small number of sounds combine into infinite sentences. A handful of weak fibers, combined by rule, becomes something the fibers alone could never be. That is not a coincidence. That is the same trick your brain uses to build a sentence out of individual, meaningless sounds. Once that trick existed, everything else became possible. A stone blade lashed to a wooden handle with sinew turns loose flint into a functional axe. A bowstring twisted from plant fiber turns a bent stick into a weapon that can kill from 100 paces. A net knotted from cord turns a single fisherman into someone who can feed a family from a lake. Rope did not just move objects. It assembled civilization out of parts that on their own did almost nothing, and then it started moving stone. Every megalithic structure on Earth, the standing stones at Stonehenge, the moai of Easter Island, the 80-ton blocks stacked into the pyramids at Giza, depended on rope the way a car depends on wheels. You cannot drag, lever, or hoist a multi-ton block with your hands alone. You need something that converts the pulling force of dozens of people into a single line of tension, strong enough to move stone without snapping. In Egypt, that technology became so central to construction that it was formalized into a religious ritual. Priests called harpadonaptai, literally rope stretchers, used knotted cords to lay out perfect right angles for temple and pyramid foundations, a ceremony called the stretching of the cord, overseen by the goddess Seshat. The earliest surviving depiction of it comes from a doorway dated to the reign of King Khsekhemui, around 2740 BCE. Before Egyptians could build in stone, they had to master rope. Geometry itself was, quite literally, tied together. And rope did not just move Egyptian stone, it held Egyptian ships together. When archaeologists uncovered the Great Boat of Khufu beside the pyramid in 1954, buried for over 4,000 years, they found a hull built almost entirely without nails. The cedar planks were sewn together with rope made from flax, threaded through drilled holes and pulled tight enough that the wood swelled against the cordage and sealed itself watertight. A ship that carried a pharaoh across the Nile, or across eternity, depending on which theory you believe, was held together by knots, not metal. From there, rope became the connective tissue of nearly every large structure humans ever built. Sailing rigging, spun and knotted, turned wind into a force that could carry a hull across an ocean, opening the age of global exploration. Suspension bridges hang their entire deck from steel cable, the direct engineering descendant of a twisted plant fiber. Elevators, cranes, and construction hoists move by cable today. For the same reason, a Neanderthal twisted 3 strands of bark 40,000 years ago. Because a rope converts weak, distributed force into strong, concentrated tension. And if you want to see the two great ancient inventions meet, look at a pulley, a wheel with a groove cut around its rim, built specifically to guide a rope. Neither invention finishes the job alone. The wheel moves things forward. Rope holds things up. Right now, a rock climber somewhere is trusting their entire body weight to a woven nylon cord. A crane operator is lifting a steel girder 80 stories into the air on a cable no thicker than a wrist. A suspension bridge somewhere is holding tens of thousands of tons of traffic above open water, using nothing but twisted strands under tension. And every one of them is relying on a principle a Neanderthal worked out in a cave in France, 50,000 years before anyone thought to write it down. Rope was never really about tying things together. It was about proving that enough weak things, arranged the right way, can hold up almost anything.